look at question 4, tutorial 6. So in this question, right, they talk about, they have a hydraulic cylinder, CD, this is a hydraulic cylinder, and it's welded to an arm. So this cylinder is welded to this arm here. So ACD is basically speaking body itself, and it's rotating at a constant rate of omega is 2.4 radian per second clockwise. So we say that this body ACD is rotating at a constant rate of 2.4 radian per second clockwise. So as an agreement to my previous what is it called explanation, I am going to still annotate this as a counterclockwise direction, like this. However, I'm going to put a negative in front of my number, just to indicate a clockwise motion. So when I were to denote the what is it called, the velocity of a point on this body, I will basically just plus 90 to the position angle, so that I can just basically get my answer. Simple as that. So the question says that knowing that the position shown, BE, is being moved to the right at a constant rate of 375 mm per second. So in this case, rod BE is not part of body CAD. Rod BE basically just a rod that has the capability to slide within this body itself. So the question asks us what is the velocity of point B and acceleration of point B? That's the question. What is the velocity of B and acceleration of B? That's a question that's posted to us. So how do we solve this question itself? So first of all, let's solve one thing at a time. Let's say velocity of B. What is the velocity of B? Now apparently, our point of concern in this question is point E, right? And we are trying to relate a point and a body. Why do we know that? Because first of all, they give us omega of a body. They didn't give us information about any other point. So apparently, we are trying to relate a point and a body. So next question is that we know the point is B. But which body? There are two bodies in this question, right? One body is body BE, and the other body is body ACD. Now, first of all, since my point of concern is B, I cannot take body BE as my reference body. Why? Because point B is part of body BE. There is no point of correlating or relating one point which belongs to the body, right? There's no point in relating a point and the body which the point resides on, because there's no meaning to that equation. It's true, but there's no meaning. So in this case, I can only relate the point B with another body, which is body ACD. So VB is equal to VB slash F, F being the body ACD, plus VB prime. Now VB prime is a position, it's a point that belongs to the body ACD, but resides on the point, but occupies the same position as point B. Now you might be wondering, for VB prime, how do you, there's no component of this body and B, so it doesn't make sense. We'll talk about that later. So let's try to fill this thing first. So VB slash F is what? Now according to the equation in the question, it says that BE is moved to the right at a constant rate of 375 with respect to the cylinder. In other words, they are trying to say that VB slash F velocity of B in the cylinder perspective is just 375 direction 0 degrees. Or it's moving to the right. That's what given in the question. So just apply. You don't need to question so much. Now, for VB prime is basically the velocity of a point which belongs to the body ACD, but occupies the same position as point B. But the problem is that the body ACD doesn't even extend towards this point here. Now, first of all, you must understand the idea of B prime in terms of the context of a body. Now, first of all, you must first accept the fact that this is a mathematical equation, and you need to give meaning to each term in order to basically visualize and conceptualize it. So, how do we define B prime? Now, first of all, I want you to do a bit of imagination. Just do not think of body ACD occupying this small space in the 2D world. What you should imagine is that body ACD is actually an infinite solid which expands throughout the universe. However, only this portion is visible. Let me repeat. You should think of ACD as a body which extends throughout the universe. However, only this ACD is visible. In other words, imagine body ACD is a large piece of transparent plastic, which only this portion here was colored using a crayon or a marker pen. So, when we talk about velocity of B prime, you are talking about a point on that transparent plastic which coincides with point B. So point B prime is also here. But it belongs to this body. Now take note that this body is rotating about A. Right? This body is rotating about A. Look at the question. So if this body is rotating about A, B prime, which also belongs to this body, taking note that this is actually an infinite plastic and this is only visible, B prime must also be rotating about A. Let me repeat. This body ACD rotates about A, so point B prime, which belongs to the body ACD, must also rotate about A. Right? So, in that case, velocity of B prime is a circular motion about A, and we can very happily say velocity point is equals to omega F times the distance from A to B prime, which is RA B prime. This is RA B prime. The distance from A to B prime, RA B prime. And the direction is equals to the position angle plus 90 degrees. So, position angle of AB prime. I'm not going to write this. So, this position angle you can find out yourself. It's just this angle here. So, this angle from the positive x-axis to here, this angle is equal to theta A B prime. And so, the velocity of B prime is equal to omega F times R A B prime, and the direction is equal to position angle plus 90 degrees. Why do I plus? So I plus 90 degrees, but you must take note that this is a clockwise direction. I annotated this way counterclockwise, but it's clockwise through the negative here. So when I were to, write this down another term, this omega F must be negative 2.4 R A B prime. Direction theta A B prime plus 90 degrees. Now, take note, this term, theta A B prime, can be found out geometrically. I'm not going to find for you, you find it yourself. It's just basically manipulation of trigonometries. R A B prime also can be found geometrically. This one is basically given. So we have the whole equation here. You just add them together using a calculator or I and J, and you get dB. That's all. Okay? So that's basically how to get the velocity of B. Now, how about acceleration of B? Acceleration of B is the same thing. Acceleration of B is the same thing. So first of all, you take a look at this. What is acceleration of B? Acceleration of B is equal to acceleration of B with respect to F plus acceleration of B prime plus omega F cross product with V B slash F. Right? Now, in this case, it says that VB slash AF is a constant. It says that point B is moving to the right with respect to this cylinder in a constant velocity. So in this case, VB slash AB slash F is 0 because it is given in the question. Acceleration of B prime is basically acceleration of this point here, which is circular motion about A, which consists of two terms, right? Centripetal and tangential. The centripetal term is just basically RAB prime omega F squared direction pointing towards the center, which is just negative, what is it called, sorry, which is just equals to theta AB prime plus RAB. Or you can put it inside as negative. This is the centripetal acceleration of the point B prime with respect to the center A. How about tangential acceleration? Tangential acceleration of the point B prime with respect to the center A is equals to 0. Why is it 0 tangential acceleration? Because angular acceleration of the body is 0. It has a constant angular velocity. It's given in the question. Now, for this term, omega F cross V B slash F, how do you evaluate this term? Now, you can do it the hard way. You can do it the hard way by doing cross product. But today I'm going to introduce you a simple way of doing VF, omega F cross V B slash F. Now, please listen carefully. The shortcut to do this equation is just basically get the magnitude of omega F, get the magnitude of V B slash F. That's all. And then the direction is equals to the direction of VB slash F plus 90. Let me repeat. Ignore this thing first. We get the magnitude for both omega F and VB slash F. Take the magnitude and multiply them together. Ignore everything first. And the direction is equals to the direction of VB slash F, theta, VB slash F. How do you get this direction of VB slash F? Basically, you get it. You can look it from the question here. In this case, the question here, the direction is 0. But I just put it as a general formula. And you add 90 degrees to that direction. After that, look at omega F. If omega F is clockwise, it's negative. If omega F is counterclockwise, it's positive. Let me repeat. How do you use a shortcut method to evaluate omega F cross VB slash F? This is my method. First of all, find the magnitude of omega, put it here. Find the magnitude of VB slash F, put it here. Okay? Magnitude is the in front term. And the direction of this term must equals to the direction of velocity of V with respect to F, which is in this case is 0 degrees, and you add a 90 degrees to it. Now after you obtain this, you look at omega F. If omega F is positive, then it's counterclockwise, it must be positive. If omega F is negative, it's clockwise, it must be negative. And the VB slash F is positive or is it negative depends on what you use here. Just copy this whole thing, put it inside. Copy the angle, put the angle here plus 90, and the omega F depends on whether it's clockwise or counterclockwise. Simple as that. Okay? Yeah. I think I'm going to repeat one more time. This term here was evaluated by plugging in the magnitude of omega F and magnitude of VB slash F. If the VB slash F magnitude is negative, retain the negative. If the VB slash F magnitude is positive, retain the positive. Get the direction of VB slash F, put it inside here, and add 90 degrees. That will be the direction of this term. For the omega F, if omega F is clockwise, it's negative. If omega F is counterclockwise, it's positive. That's all. And for VB slash F term, it can be negative. If initially your VB slash F is negative, then you put negative inside. If your VB slash F is positive, you put positive inside. Just copy and paste. Magnitude. Not magnitude, the absolute term, not absolute term, the term in front of the angle. Okay? And that will be your acceleration of B, because you know R AB prime, you know omega F, you know angle AB prime, which is this angle, you know omega F, you know VB slash F, you know theta VB slash F. Then everything, add them together, you get an answer of acceleration of B, and you can get the answer for this question. So, just to recap, how would you solve it? Now, I know this thing is a bit too much to absorb, so please try to pay attention step by step. Let me do a very quick summary review. First of all, how do you find VB? Lay out the equation. After I lay out the equation, look at the question. What are the information I have? And I put in this information from the question. And from this information and understanding through analyzing what is the motion of B prime. In this case, the motion of the body is a circular motion. It's rotating about A, so B prime must be a circular motion about A. And I establish this equation. Take note that theta A B prime is a position angle of B prime with respect to A. Now, after I solve the velocity equation, I have my VB slash F. And I can solve my acceleration equation. In my acceleration equation, my AB slash F is 0, given by the question. My AB prime is basically a circular motion, and it only consists of centripetal acceleration because the angular acceleration is 0. It says it's a constant angular velocity. And the final term here was simplified by, first of all, using by substituting the magnitude of term, and the direction is equal to the direction of VB slash F plus 90. Now, when I say magnitude, I don't mean making it an absolute number. It means that if your VB slash F, the front term before the horizontal angle is negative, put a negative inside here. If it's positive, put a positive inside here. For omega F, if it's a counterclockwise direction, put a positive. If it's clockwise, put a negative. That's it. Alright? So we'll go to the next question, the last question. Sorry.